Welcome to the lecture on performance measures of a queuing system. So, in this lecture we will talk about the different performance measures in a queuing system. Before that, in the last lecture we were discussing about the queuing notations, and as we discussed that there are normally 5 or 6 terminologies, 5 or 6 terms. Normally we will discuss about 5 terms which are used in the queues, and these terms are known as A, B, C and K. So, this is the normally notations which are used in queues, and as we know that this A is normally talks about the arrival rate distribution or inter-arrival time distribution. So, A will be inter-arrival time distribution, then B will be the service time distribution, and C is the number of servers, and N is basically the system capacity, and K is calling size, calling population size. So, as we discussed that you have these 5 terminologies which will be coming normally. So, that is A, B, C, N, K. Inter-arrival time distribution is normally it is Poisson distributed. Inter-arrival time is basically then exponential distributed. Then arrival number of arrivals will be Poisson distributed. Similarly, you have Poisson process. Similarly, you have B is service time distribution, that is how much. So, this is basically talks about the time between n minus 1 and n customers. So, if we talk about an means the time between n minus first and nth customer. So, like that. Similarly, bn means it is normally the service time for the nth customer which has arrived. C will be number of servers. So, you may have one number of server, you may have more number of servers, multi server, single server. System capacity, it may be finite or infinite, and the calling population size will be finite or infinite. So, normally what is done is when this is following that Poisson distribution or exponential distribution, I mean depending upon what we take in, if it is the inter-arrival time exponential distribution, if it is the number of arrivals in certain time, then it is again the Poisson process. So, that is basically said to be a Markovian type of distribution, and it is represented by M. So, M, this will also be known as M, and this is if the server is 1, in that case it is MM1. So, MM1 is normally the queue which talks about Poisson distributed service. So, Poisson distributed arrival and service, and then C is the server, that is 1. So, that is normally the queue notation, and these two will be normally infinity. So, that infinity need not be written every time. So, this way a queue is denoted. Now, so common symbols for A and B, as we discussed, are M is Markovian, or exponential, D, we also talk about D when it is deterministic or fixed. So, it will be constant or deterministic. Similarly, you may have Erlang distribution with kth order, when it happens in phases. You may have other also kind of symbols for A and B, but normally we go for Markovian in most of the cases. So, when it is Markovian arrival and service rate and there is one server, it is MM1, and if both are infinity n and k, then MM1 infinity infinity, and normally it is represented by MM1. Now, you have certain queuing notations which we must know. You have some terminologies which we will come across when we talk about the queues. So, among them one is Pn. So, when we talk about Pn, means you want to see the probability of having n customers in a steady state system. So, it is steady state probability of having n customers in system. So, this is basically the steady state probability values. Then if we talk about P and T, it means this talks about a time. So, it is the probability of having n customers at time t. So, this is the one. Next is you have lambda. Lambda is the arrival rate. Similarly, you have mu, that is service rate. So, this talks about also service rate. Then comes rho, that is server utilization. We are also interested to know, as we discussed, that for what fraction of time the server was busy or it was idle. So, that is basically calculated using this factor value, server utilization. Then you have, so as we discussed, AN means A1, A2. This talks about the inter-arrival time between n minus 1 and nth customer. So, as we discussed that the arrival may be given in terms of the number of arrivals in certain time, or it may be given as the inter-arrival time between the customers. So, if the inter-arrival time between the customers are given, in that case the time of arrival can be computed by adding those times, whatever has happened earlier. So, that way the arrival time can be calculated. So, AN, that is A1, A2, these are the inter-arrival times. Similarly, SN, it is used for the service time of nth arriving customer. So, S1 will be the time required for the first customer to get the service, that is S1. Similarly, S2 is for the second customer to get the service, that is time required. So, that this is given by, that may be a fixed one quantity, or that may be given by a probability distribution function or so. Next is you have Wn. So, this is known as total time spent in the system by nth arriving customer. In system. So, it will be Wn is total time spent by nth arriving customer in the system. In the system means as long he is getting the even the service. So, that is the total time spent by that nth arriving customer, and if we take Wn cube, when we put this q, that basically the same thing, but it will be in the q. So, it will be total time spent by nth customer in q. So, it does not take the time into account when the customer joins the queue. So, it will talk about the time till it is before the customer who is getting the service. Once that customer departs, then he joins the queue. So, this is basically the waiting time for the customer. So, that you can also tell like the waiting time for the customer, nth customer in queue, and waiting time for the customer in the system, that is S. Similarly, you have another one. So, when we talk for the nth customer, that is Wn, and when we take W, that is long run average. So, long run time average when we talk about, so as and is tending towards infinity. So, that is known as long run average time spent by a customer in system. So, when we talk about the long run average time spent by a customer in system, that is W. Similarly, you have WQ. So, that will be for same thing, but when it is in Q. The next parameter which is, that is LT. LT is the number of customers in the system at time t. So, and then, so this is the number of customers in system at time t, and if you talk LT cube, so that is basically number of customers in Q at time t. So, if we talk about L and LQ, L will be average number of customers in system, so that is long run time average number of customers in system, and long run time average number of customers in Q, that will be LQ. So, this way you have L and LQ. So, you have when L, or you may have LQ, that is long run time average number of customers in system, and similarly you have long run time average number of customers in Q. So, this way these are the notations, these are the terminologies which we will come across when we discuss about the queuing behavior. So, we will be finding certain values, we will be having certain values, and we will be finding certain values when we analyze the queuing system. Now, we will move to the typical performance measures in a queuing system. So, the typical performance measures which are normally we are interested in, will be time average number of customers in the system. If it is time average number of customers in the system, it is Ls, and if it is in the queue, it will be Lq. Similarly, average time spent in system, that is Ws, and average time spent in the queue will be Wq, and the server utilization. So, how they are basically calculated. So, that can be seen by looking at. So, as we know, the time average number of customers in the system or average time spent in the system. So, any person who is spending how much of time, and total time, if you divide it, so that will be that way it is calculated. So, we will solve for a problem which is, then it will be more clear that how it is computed. So, let us see, this is the number in system LT at time t. If you look at this graph, here what we see is it is in the system. So, at time t. So, what we see is from 0 to 2 seconds or 2 minutes, whatever it be, the unit be, you have one number of person in the system. So, he came at 0 time, and in the system there is one person. It means that there is no person in the queue. So, he has come and he has joined the queue. So, he has not to wait in the system. He has gone, and then after that in the system there is no one. So, it has gone. It means this person who has come, he has left the system at time 2 seconds or 2 minutes. So, let us say it is taking minutes. So, in 2 minutes he is going out of the system. Then again in the system you have the number 1 at time 3 minutes, then at time 5 minutes this number goes to 2. It means the person has come here. So, second person has come here, second person's arrival is at time 3 minutes. At this point at 5 minutes the third person has come, and at this time you have at 7 minutes you have the third person coming, second, third and fourth person is coming. So, at this point you have number of persons in the system is 3. So, at this point if you look at from this time to this time, for this duration you have 3 persons in the system. At this point one person is coming out of the service. So, this is the second customer, because this customer who has come here, and if we assume that this is a general discipline, first in first out, in that case the second customer will leave this system at this time. Then the third customer is going to leave at this time, fourth customer is going to leave at this time, fifth customer is coming at this time, and then sixth customer is, so fifth customer is going at t equal to 20. So, this time he is going. So, what we see is that the server is busy since beginning up to 2 minutes. From 2 to 3 minutes it was not busy. Then it was busy from 3 to 14 minutes. From 14 to 16 minutes it was not busy. Then from 16 to 20 it was again busy. So, as long as the server utilization is there, out of 20 minutes we see that for 3 minutes it was not busy. So, utilization of server is 17 by 20, that is 85%. Now, the thing is that this graph tells us about the number of customers in the system, but there is another parameter which is to be calculated, that is number of customers in the queue. So, from this graph we can find how many number of customers are there in the queue. So, number of customers normally in the queue will be LT minus 1. So, normally when it is 1, the number of customers in the queue will be 0. So, the number of customers in queue LQ, that will be 0 from 1 to 2, 0 to 2 minutes. Similarly, it will be 0 from 3 to 5, but it will be 1 in this period, it will be 2 in this period, it will be again 1 in this period, it will be again 0 in this period, it is anyway 0 in this period, and it is again 0 in this period. So, that is the number of customers in system, not in system, it is in queue. So, this is in the system, and when we try to find the LQ, that time it will be lessened by 1. So, this way this quantity is to be calculated. Let us calculate what will be the average number of customers in this system. So, we will find time average number in system. Now, let us first find the expression for these quantities. So, if LT that basically denotes the number of customers in system at time t. So, now we have the time horizon up to 20 minutes. Now, if Ti denotes the total time during 0t in which system exactly contained I customers. So, this Ti, that is the time duration for which, so 0 to t. Now, if Ti is that time duration during which the system had I number of customers. So, in that case I into Ti upon t. So, that will be now. So, what happens, first of all, summation of Ti I from 0 to infinity, that will be t. So, in that case L, this will be, that is time weighted average number of customers in system it will be nothing but 1 by t summation of I equal to 0 to infinity I t I. So, time weighted average number of customers in the system, it will be I t I. So, for t I duration you have I number of customers, and then we are basically averaging because of the total time, from the total time. So, it is 1 by t. So, this way you can get the average number of customers in the system. Now, you can further find this, because t being constant, you can write it as I Ti upon t. So, this way Ti upon t is the proportion of the time when system contained exactly I customers. So, this Ti by T, what is this time? This time is that proportion of time during which we have number of customers equal to I. So, this is proportion of time during which system contained exactly I customers. Now, if we try to find using this formula average number of customers in system, then we can find from this graph. So, what we see is you have 0 number of customers between 2 to 3 and 14 to 16. So, I when it is 0, T I will be 3. So, it will be estimated value we are finding. So, that will be 0 into 3 plus you have one number of customers in the system for how much time? This is 2 plus again 2 4 plus 4 8 plus 4 12. So, you have 12 time units, and at that time you have one number of customer in the system. So, I is 1 and this is 12. Then we go to I equal to 2. I equal to 2 will be from here it is 2 plus 2 4. So, 2 number of persons into 4. So, it will be 2 times 4, and similarly you have 3 customers, I number of I is 3 for 1 minute. So, 3 into 1 and whole divided by T. So, T is 20. So, this is coming out to be 12 plus 8 20 plus 3 23 upon 20, that is 1.15. So, 1.15 average number of customers are there in the system. If we talk in the queue, if we talk average number of customers in queue, so what will happen in average number of customers in queue when we talk about average number of customers in queue? As we discussed, average number of customers in queue, in that case that value LQ will be basically 1 less than this value. So, this will be again 0, it will be 1. So, 0 into, so for this it will be 0, this will be 1, this will be 2. So, 1 into 4 plus 2 into 1. So, it will be LQ, and that will be 1 into 4 plus 2 into 1 by 20. So, 0.3 customers. So, this is how the average number of customers in the queue can be found. Then we can also find the server utilization, as we discussed that by looking at this graph or this figure you can find the server utilization, and server utilization will be basically 17 minutes divided by 20 minutes. So, it will be 0.85. Now, we can also find the average time spent by the customer in the system. So, average time spent in the system by a customer. So, per customer we can find the average time spent by a customer. So, the second parameter, that is server utilization. So, server was utilized, it was not utilized from 2 to 3 and 14 to 16. So, it was utilized for 17 minutes out of 20 minutes. So, it is 0.85. So, that basically you can find it from a graph, and on that this time horizon you have something like this. If we take it as, if the 1 indicates, so you have 2 to 3 is, so 2 to 3 was, it was idle. Similarly, you have from 14 to 16 it was idle. So, it was 14 to 16 it was idle. So, this way, this fraction from here you can find that the what is the time the server is busy or it is idle. Then another parameter which can be found may be that time spent by the customer, average time spent by the customer either in the system or in the queue. So, that basically you can, in the system, how much is the time spent, that you can see that how long he was there in the system, and then you can divide it further by the number of customers. So, per customer you can find. Similarly, in the queue, how much he has spent, how much time he was in the queue, you have to remove the time for which he was there on the server. So, this way you can find those things. Maybe we can discuss about these findings in the next course of lectures, where we will discuss about these performance measures calculation, and also we will see how they are programmed, how they are simulated using the computers. Thank you very much.